So, man-made hot fusion has apparently now produced more energy than was used in the fusion process. So what actually is going on here, and why doesn't it break the laws on the conservation of energy? Let's deal with that last issue first. The energy produced is nuclear energy, so the energy already exists locked up in the atomic nucleus. Now if you can fuse two lighter elements together, they will release energy, which is a process which also fuels our sun. If you were to reverse the process and split up the atom produced by nuclear fusion, you then require energy to do so, which means that the energy isn't magically created out of nothing. Likewise, if you split up heavier elements like uranium, you release energy. And this fission energy is commonly found in current nuclear power stations and many nuclear bombs. If you try to fuse the elements produced by nuclear fission back together to return to the original element again, you would require energy to do this. So the energy which is being used up in the hot fusion process isn't being used directly as fuel as such. Instead, it's being used as a kind of catalyst to make the process actually work. So listen to the question, how does this actually work? Well, most of us were taught in schools there are actually three states of matter: solid, liquid, and gas. There is actually a fourth state, which is plasma. At the basic level, you heat hydrogen up by a phenomenal amount. Hydrogen goes into a very hot gas. Then, as the atoms heat up even more, at this stage, electrons orbiting around the atom become detached from the hydrogen nucleus. At this stage, you now have plasma. In nuclear fusion, you need tremendous amounts of pressure to force the hydrogen to join with each other. But under most circumstances, pushing hydrogen atoms together is impossible. Firstly, the electrons orbiting the atoms act like a kind of bumper car rubber ring around the atoms, preventing the nucleus from even getting near each other. So by turning hydrogen into plasma, you remove this outer barrier to the fusion. However, the hydrogen nucleus is positively charged, so it still doesn't want to fuse with another positively charged nucleus. So along with the exceedingly high temperatures and high density of the hydrogen nuclei, you still need an incredible amount of pressure to force them together. And once this fusion of the nucleus actually takes place, it would then release the energy. So man-made hot fusion process use the energy for two purposes. Firstly, in heating up the hydrogen and turning it into plasma, and secondly, applying the pressure to the hydrogen plasma. According to the result of the recent experiment, they've managed to release slightly more energy from the fusion process than was used up in making it happen. However, still a very long way from making cheap fusion power a reality. Firstly, the results need to be checked and double-checked to see if the reported results are correct, so there have been issues with fusion claims before. At first glance, it does also seem not to be measuring the amount of energy used, just the power output from the devices like the laser, not the power used by the laser. So since the device is not 100% efficient, there may not actually have been an energy surplus produced at all. Next, this has all been done in laboratory conditions, so doing it consistently so we can gain a regular flow of power out of this needs some serious changes to the way it was actually done. Final issue is the construction of the device to create the fusion is exceedingly expensive and uses up a lot of power just to get slightly more power out. So while you may get a little bit of free energy out of it, you have to put in massive amounts of energy just to get a tiny additional bit back. The current energy surplus is not going to be economical. You either need to use less energy to create the fusion process, or be able to fuse a great amount of hydrogen at a time. This hot fusion experiment is just the first positive step in creating hot fusion power, but it isn't the finished article. Now, although I've said using hydrogen to fuel the reactor, that isn't exactly the case. What they're using is deuterium and or tritium. These are the heavier forms of hydrogen. The standard hydrogen nucleus is a single proton. Deuterium has a nucleus of a proton and a neutron, making it heavier than standard hydrogen. While deuterium is not common, it isn't that rare. It can be relatively simply extracted from seawater in the form of heavy water. Tritium is more awkward as it has a nucleus of one proton and two neutrons. Unlike deuterium, it's very rare in nature as it actually decays. Tritium can be artificially created. Now, if you fuse one atom of tritium and one atom of deuterium, you have a nucleus of two protons and two neutrons, or a helium nucleus. In addition, you also gain a spare high energy neutron which is actually released.